Do you want to get full marks in your physics examinations of pre-boards ICSE? Well, this is the physics paper of the final examination of one of the reputed schools. Go through this paper, pause the video whenever you can, write the answers, and I have solved this entire paper so you can check your solutions with my solutions. Okay, so shall we begin? Section A, which is of 40 marks. Like all the ICSE pre-board examinations, this paper will have section A, which will be of 40 marks and will have all questions in section A compulsory. Whereas in section B, you will have to solve 4 questions out of 6. And each question will be for 10 marks. And I've decided to solve this paper for you so that you will benefit from the solution of this paper. You will come to know where we lose mark and all the information will be given regarding the presentation of your work. So, shall we begin? Let us look at our question 1. Name the quantities measured in the following units. 1 parsec, 2nd solar day, 3rd micron, 4th light sec, and 5th one is bar. So we write question 1A and we write here the unit and then we write here the quantities. Parsec is the distance between heavenly bodies. Solar day will be the time. Micron will be length of minute objects. Light second, astronomical distances. Now we are used to light years, which is the distance of the stars from the earth. But light second also will be how much light can travel in 1 second, that is 3 into 10 to the power 8. Again, these ones are large distances. 5th one is bar, that is for atmospheric pressure. Let us come to question 1b. Convert the following as directed: 25 nanometers to meter, 40 gigahertz to hertz, 6500 kg to metric ton, 5 into 10 to the power minus 7 mu to meter, and 125 meter to angstrom unit. So we write 25 nanometers to meter. So we will have 1 nanometer is equal to 10 to the power minus 9 meter. So 25 nanometers will be 25 times 10 to the power minus 9 meter. When we are presenting a number like this, we do not write 2 digits, we'll write 1 digit and a decimal. This is the standard international format of representing numbers like this. So 2.5 we get because we have divided 25 by 10, correct? So here we will multiply it by 10. So you will see that this 2.5 and this 10 does give us the same quantity here, 25, but now we will present it as 2.5 multiplied by 10 to the power minus 9 plus 1 means minus 8 meter. And this is our answer 1. For our second subpart, 40 gigahertz to hertz. Now 1 gigahertz is 10 to the power 9 hertz. So 40 gigahertz will be 40 into 10 to the power 9 hertz, and that will be equal to 4 into 10 into 10 to the power 9 hertz. As I told you, we write it as a single digit and a decimal. So we will write it as either 4 or 4.0 multiplied by 10 to the power 1, and this 9 will give us 10 to the power 10 hertz. And this would be our answer 2. The third one, so many kgs to metric ton. Now we know that 1000 kg corresponds to 1 metric ton, and so 6500 kg will correspond to 6500 upon 1000 into 1. Cancelling the 0, you will have this equal to 65 upon 10 means 6.5 metric tons. And that would be our answer 3. Let us come to the fourth subpart. 5 into 10 to the power minus 7 mu means micron to meter. Now how much is 1 micron? 1 mu or micron is 1 micrometer, and we have 1 mu or micron or micrometer is 10 to the power minus 6 meter. We need to know these conversion factors. So therefore we will have 5 into 10 to the power minus 7 microns will correspond to 5 into 10 to the power minus 7 into 10 to the power minus 6, cross multiply, divide by this, those many meters. So that will be equal to 5 into 10 to the power minus 13 meter. And this is our answer 4. We come to the fifth subpart, 125 meter to angstrom. Now we know that 10 to the power minus 10 meter is 1 angstrom. So 125 meter will be 125 into 1 divided by 10 to the power minus 10. And that would give us 125 into 10 to the power 10 angstrom units. And if we still would like to convert this into 1.25 into 10 to the power 10 angstrom. Now remember, this 1.25 has come from 125. So we have to multiply 1.25 by 100 to get 125. So it will be into 10 to the power 2, which gives us 1.25 into 10 to the power 12, these many angstrom units. And this is our answer for the fifth subpart. Question 1c. Write the MKS unit for the following quantities: torque, momentum, pressure, power, work. So here we have made the table. There's quantities and the MKS units. Now torque is the turning effect is Newton meter. But when we write MKS system, you have to write this Newton meter as Newton means kg meter per second square, that is Newton, multiplied by meter. So this becomes kg meter per second square into meter, which is kg meter square per second square. Momentum. Now momentum is denoted by P, which is m into v. So m is in kg and v is in meter per second. Only thing is that I will write it like so, but when you write, spell it out. You say kilogram meter per second, okay, for each one of these. Pressure. Pressure is thrust upon area. What is thrust? It is the force, which means it is Newton upon meter square. So it becomes Newton means kg meter per second square upon meter square. So we will have 1 meter getting cancelled here, and we will have kilogram per meter per second square. and that is the MKS unit. You have to spell it out as I told you. Power. Now power is work upon time. So work is force into displacement. So force is going to be kg meter per second square. This is your force into displacement is meter, and that upon time is again second. So it becomes kg meter square per second cube, and that is kilogram meter square per second cube. Then we come to work. Work is force into displacement. So work will be, I'll write it in this line over here. So it will be force is this into displacement is this. So kg meter square per second square. But in the exam, please spell it out. This one is your work. We now come to question 2a. State the number of images formed for an object placed asymmetrically or symmetrically. What are they saying? Symmetrically. Between the two plane mirrors kept at 70 degrees. Now, if the object is kept symmetrically, you are going to have 360 upon theta equal to n, and the number of images will be n minus 1. So let us show the working. If theta is 70 degrees, the number of images formed are going to be 360 degrees upon theta, that is 70, and that you have to subtract 1 from. So that will give us here, this will be 5/1/7 minus 1, and so it is going to be 4/1/7. Now are we going to get 4/1/7 image? No. So you will say therefore 4 images. Now if the mirrors are parallel, then our theta is going to be 0 degrees. So the number of images will be 360 degrees upon 0 degrees. That is going to be multiple images. So we will say infinite images. Form. Let us look at 2b. Without touching the mirrors, how will you identify the type of spherical mirrors? Now the spherical mirrors are either convex or concave, but you're not supposed to touch them, right? So we are going to take a printed page next to them, and we will write the answer like so. Bring a printed paper in front of each mirror. If the print is upright and magnified, then it is a concave mirror, because concave mirror gives magnified upright image when the object is between the principal focus and the pole. If the print is upright, but if it is diminished, then it is a convex mirror. Why? Because convex mirror will give virtual diminished image of any object placed in front of it. Did we touch it? No. So this is our answer. Question number 2c. Draw the ray diagram to obtain an image from a mirror of large focal length so that the object lies within the focal length. Also name the mirror used and state the characteristics of the image. Now tell me, when we have to have the object within the focal length, then that means the object is between the principal focus and the pole. And why would we do that? To obtain the magnified image. So this will have to be the concave mirror. Okay, so large focal length is only so that the face can fit in. So it is when we use it as a makeup mirror or the shaving mirror. Don't write makeup mirror, write shaving mirror. Okay, so let us see how we draw the diagram. Mirror of large focal length so that the object lies within the focal length, which means it is between F and P. So you draw this, this is the principal axis, you label it. Then we have the concave mirror, show the quoted side, and this is the reflecting side, and you label it that it's a concave mirror. From here to here you can take about 2 to 3 centimeters, but take exactly the same. If you've taken here 3 centimeters, which I have, and from here to here if you take 3 centimeters, then your diagram will be more accurate. Show the object like this, upright, AB, and then first ray goes parallel to the principal axis and it goes through the principal focus like so. And the second ray goes through the center of curvature, but it gets reflected back like this. Now can you see these are divergent rays? So if you have the eye in front of it like so, then these rays will be entering the eye and the rays appear to be coming from here. So when you take the ruler, use the ruler like this and immediately draw this dashed line. Then take this point and this point, join this, and then let it come up to the mirror because it gets reflected back from the mirror surface, and then produce it backwards like this dashed line. And then we take this point of intersection, and this is where the image will be formed. So we show it as dotted line because it's a virtual image, and we label it as A dash B dash. So these are our labels. We have to state that AB is the object, A dash B dash is the image, and we will say that it is the concave mirror. And also the characteristics of the image, you can write them one below the other. The first one is that it is virtual, it is magnified, it is upright, and it is behind the mirror. So 4 characteristics, you will write 1, 2, 3, 4 like that, one below the other. Okay. Question number 3A has this graph and it's a velocity against time graph. Look at our first question. Identify the uniformly accelerated motion. Calculate the acceleration for that time period. Uniform acceleration means the velocity is increasing. Now from A to B, the velocity is constant, and from B to C, the velocity is increasing. So it is going to be your BC. And calculate the acceleration. Remember, acceleration is V minus U upon T. So initial velocity is 20, final velocity is 60. So it becomes 60 minus 20, and the time from here to here is 20. So it is 40 upon 20, which gives us 2 meter per second square. And that is our answer 1. Let us come to the second subpart. Identify uniform velocity from the above graph. Uniform velocity where the velocity is constant. So that will be AB and CD. At AB it is 20 and at CD it is 60 meter per second. Calculate the velocity at that time interval. So we will write uniform velocity is during AB and CD. Now at AB the velocity is 20 meter per second, and for CD it is uniform velocity of 60 meter per second. Let us come to the third subpart. Identify the retardation motion and calculate the retardation. Now retardation means the velocity is decreasing. Can you see during DE it is going from 60 to 0. So we will say retardation is during DE. Underline that. And for the retardation is negative acceleration. Remember, acceleration is V minus U upon T. So your V is going to be 0 and your initial velocity, that is U, is equal to 60. So we will write 0 minus 60, and that happens during this time, that is 10. So we have this meter per second upon 10 second. So that gives us minus 60 upon 10, which is minus 6 meter per second square. And we will say therefore retardation is equal to 6 meter per second square. And that is our answer 3. Calculate the total distance covered by the body during its motion. Now the total distance is going to be the area which is trapped by this graph and the x-axis. That is the total distance. Now if you call this as area 1, area 2, area 3, area 4, and if this is E, then we'll call this point as F, G and H. Now you will have to just show this diagram in short, and then you can say it will be area 1 plus area 2 plus area 3 plus area 4. Okay, so now let us write it from here. Your area 1 is going to be, this is 20 and this is 10. So it will be 20 multiplied by 10 plus area 2. This is a trapezium. So for the trapezium, it will be half sum of the parallel sides. This and this, they are parallel. And how much is this? 20. How much is this? 60. So it will be 20 plus 60, and the height is this. Can you see that? These are parallel lines. So you'll have to turn this paper sideways, rotate through 90 degrees, and you will see these two are parallel sides, and this becomes the height. When this is the height, it will be from 10 to 30, that means 20. So the height is 20 plus area 3. Area 3 is a rectangle. From here to here, 50 minus 30, that is 20, and CD is corresponding to 60. So it becomes this 60 multiplied by this 20 plus area 4. Area 4 is a triangle. So it becomes half base into height. Base is between 60 and 50. The difference is 10. That's the base. And the height is up to the CD level. CD again, this is 60 from here to here. Okay, so your DF is going to be what CD is corresponding to. So that is 60. 2 ones, 2 tens, 2 ones, 2 fives. Okay, so let us see. It becomes therefore 200 plus this will be 80 into 10, that is 800, plus 6 2's 12, so 1200, plus this is 6 5's 30, so 300. So this is 1000, this is 1000 plus 1200, that is 2200 plus 300, so it is 2500 meter. This is the total distance that is traveled. That is actually 2.5 kilometers. Next one is state the law of inertia. We will say law of inertia, underline that, and say states that a body continues to be in its state of rest or state of uniform motion unless an external force acts upon it. So that finishes our question 3. Now we come to question 4. Question 4 is very simple. It's just learning work. 4a says define induced magnetism and then draw the magnetic field lines of a bar magnet. Are they uniform or not uniform? And how does the magnetic field lines of the earth appear near the magnetic poles and equator? So let us see how we present that work. So we've written question 4a, first part, induced magnetism, and the definition, temporary magnetism acquired by a magnetic material when it is kept near the magnet. Second question was draw the magnetic field lines of the bar magnet. Now for this bar magnet, we will show a rectangle like this and we mark it north and south, north polarity, south polarity, and magnetic field lines start from north and end up in south. Now we show this, basically it looks like a butterfly, right? Now remember, the magnetic field lines have to be shown as dotted, so draw like this lightly and just take your eraser and do this. Can you see this shortcut? It's a good shortcut, yes? See how fast we can draw the dotted lines? This is the easiest way of drawing the magnetic field lines. It's the easiest way of drawing the magnetic field lines. So now this is done. Next question was, how is the Earth's magnetic field near the poles and near the equator? Now at the poles, it is perpendicular to the Earth's surface. Remember, the Earth will be like this way. So the magnetic field lines will be here perpendicular. Okay, but for the equator, they will go this way. So they will be parallel to the Earth's surface. So that is what the question is asking us. So at the equator, they are parallel to the Earth's surface. Question number 4b. How does the speed of sound in gas change when the temperature of the atmosphere decreases? Now when you write this question 4b, we will say speed of sound. Our thinking step is that speed of sound v is directly proportional to root of temperature. Okay, decreases with decrease in temperature. Now the second part is when the density of the air decreases. Now your thinking step is velocity is inversely proportional to square root of density. So if the density is decreasing, the speed of sound is going to be increasing. So we'll say it increases with decrease in density. Underline decreases, underline increases. Then we come to part C, define neutral point. Now this again is a learning work. What is neutral point? We will say neutral point is the point in magnetic field where the resultant magnetic field is zero due to equal and opposite magnetic field. And that finishes our section A. So once we finish with section A, I'm going to start with section B, but that will be in our next video. Okay, so as of now, we are going to stop here. All the best for your examination. If you have an examination approaching, stay safe, stay healthy, and all the best. Bye.